Over 95% of the world uses petrol and diesel combustion engines now, and even by 2020, 90% still will be. That leaves only 10% using alternatives. Cars that run on electric, hydrogen and biofuels have potential, and we're working on alternatives too. But the solutions most car makers have come up with so far either offer up the driving exhilaration of a couple of squirrels on a treadmill, or are so expensive they're just not realistic for most people. To really affect global fuel consumption and emissions right now, you have to use something the globe actually uses right now. Rethink the combustion engine, make it better and accessible to everyone, and you'll make a difference. A big difference. How big? Consider that current combustion engines waste about 70% of the fuel's potential energy. That's a lot of room for improvement. Our overall goal was to get 15% better fuel economy and a 15% improvement in low mid-range torque from the same engine, all on regular fuel. Two enormous gorillas stood in our way. The first was figuring out how to capture more energy from the fuel. To achieve this, we knew we had to raise the compression ratio, which gives us a bigger power stroke in the combustion chamber. The higher the compression ratio, the more energy you get from the combustion. But a high compression ratio usually ends up causing knock, which is when the air-fuel mixture ignites too soon because it's too hot inside the chamber. So we had to cool things off. Using some huge engineering muscle, we came up with innovative solutions to do just that. Like a high-pressure 6-hole direct fuel injector that fires petrol into the cylinder in stages for a more stable air-fuel mixture. And a little volcano-like pocket in the piston that gives the early part of the explosion a place to go, without heating up the top of the piston. To get all the hot exhaust out without it shooting into the other cylinders, which only heats things up again, we added a longer exhaust manifold used in race cars called a header. Everyday cars don't use headers because of the emission problems they create, but our advanced direct injection system solved that issue too. That's how we got more energy from the fuel. The second gorilla was making sure we weren't losing any of those improvements on the way to the wheels. So we reduced friction inside the engine by a whopping 30%. How? By sweating every little detail. We've improved oil pump efficiency by 74% and water pump efficiency by 31%, reduced friction from the moving parts, like the pistons, rods and crankshaft, by 25%, reduced valve train friction by 54%, and even reduced the effort the engine exerts to suck in fresh air by 13%. When it was all over, we had done what couldn't be done, achieving more torque, better performance and higher efficiency. Skyactiv technology from Mazda. Imagination drives us.